Video we're going to take a look at increasing and decreasing functions along with the first derivative test. So we know that this is an increasing function, this is a decreasing function. So simply put, this is increasing, it goes up as it moves from left to right. This goes downward as it moves from left to right. So if we draw the tangent lines along each of these graphs, it'll show that in the increasing function, the tangent line is always positive. So f prime of x is always greater than 0. In this decreasing function, we'll find that the tangent lines are always negative, which means that they are less than 0. So f prime of x is less than 0. So we use critical numbers to separate the increasing and decreasing functions. For example, let's say we have a graph that looks something like this. We have a critical value here, 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 and here. So the slope of the graph here would be 0, 0, 0, and does not exist. So if we plugged a number in here, we would find that f prime of x is less than 0 because it's decreasing. If we plugged a value in between these two x values, we would find that f prime of x is greater than 0 because it is increasing. If we plug a value in here, we'll find f prime of x is less than 0 because it is decreasing. Same goes for this column. We find that f prime of x is greater than 0 because it is increasing, and f prime of x is less than 0 because it is decreasing. So we know that a relative max or minimum has to occur at a critical point. So to find the relative extrema, we will use the critical points. Now there can be 4 possibilities. One where f prime of x is greater than 0. We have a critical value at C, and then f prime of x is less than 0. Now we know that this increase is increasing, this function would be decreasing, so we would have a relative max at x equals c. Now our second possibility, we have a critical value, and we find that f prime of x is less than 0, so it is decreasing, and f prime of x is greater than 0, so it's increasing on this side. This will be a relative minimum at x equals c. Now, another possibility is a critical value. To the left of our critical value, we find that f prime of x is less than 0. And to the right of our critical value, we find that f prime of x is also less than 0. So it looks something like this. And then in this example, we would have no relative maximum or minimum. And our last possibility, we have a critical value where to the left f of x is greater than 0, to the right f prime of x is also greater than 0. So this will look something like this. Also no relative extrema. Let's go ahead and try a few examples. We have 3x squared minus 4 equals 0. So we're going to find the first derivative of this. It would be 6x. Let's try x to the third minus 4x. So we have 3x squared minus 4. 3x squared equals 4. X squared equals the square root of, or x equals the square root of 4 over 3. So we know that we have a critical value at negative square root 4 over 3 and square root 4 over 3. Now we plug value less than negative square root 4 over 3 back into this equation. So let's say 2, we get an 8. So it is increasing here. Now let's plug something between these two values in, say 0. We get a negative 4. So it is decreasing. And a value higher than square root of 4 over 3, let's say 2, we get that it is increasing. So we know that there's a relative maximum here and a relative minimum right here. To find the y values, we know that the x value is negative square root 4 over 3 and square root 4 over 3. Now to find the y value, we would just plug it back into our original equation. So we'd plug our critical numbers in for x to find y. Let's try another equation, x squared minus 4x. So we're going to differentiate. We get 2x minus 4 equals 0. 2x equals 4. X equals 2. So we know we have a critical point at 2. So plug a value less than 2 in, say 1. Minus 4 is negative, so it's decreasing over here. And then a value higher than 2, let's say 3. 9 minus 12. We get 6 minus 4, which is increasing. So we know we have a minimum at 2. Now to find the y value, we would plug this back into the original equation. So I'll go ahead and do that. So we have a minimum at 2, comma, negative 4.